In process technology, thermocouples are usually designed as head thermometers or mineral-insulated elements. Thermocouples consist of two legs of different metals or metal alloys, which are welded together at the point of measurement. The elements output a voltage from which the measuring temperature is determined. The thermoelectric voltage in the legs results from charge displacement. The higher electron density in the colder region results from the lower velocity of the electrons at lower temperature. The voltage in the second leg is present at different levels due to the different material. The resulting total voltage is used for temperature measurement. Thermocouples are consumable due to their increased drift behavior and should only be used when the use of RTD temperature probes is not possible. The main reason for use is temperatures above 600 centigrade Celsius. The thermocouples used in process technology are defined in DIN EN 6584. The most common ones are shown here. Among other things, the characteristic curves are standardized, and thus the thermocouples are interchangeable. The standard also specifies recommended maximum temperatures for the thermocouples. Thermocouples have a polarity. According to the standard, the negative pole is always in the color white. The colors given here are used for the positive pole and the sheath. The thermoelectric voltage arises via the temperature profile. Here the ratios are shown for the widely used Type K thermocouple. If connecting material is required for the connection of thermocouples, as in the case of thermometers with connection heads, connecting wires with the same thermoelectric properties must be used. These are so-called compensating cables. For example, for a Type K thermocouple, a Type K compensating cable must be used and connected with consideration of polarity. If, for example, copper cables are used, the measured thermoelectric voltage is lower and incorrect measurement occur. The point at which the thermoelectric voltage is measured is the reference junction, and the temperature at this point is the reference junction temperature. When the thermocouple is connected to a field device, the reference junction is located at the connection terminals. The respective thermoelectric voltages for a reference junction temperature of 0 centigrades can be taken from tables or calculated from formulas. This option allows the measured temperature to be determined from the measured thermoelectric voltage. The reference junction temperature is usually not at 0 centigrades, and so the field device must perform a so-called internal temperature compensation. In addition to the thermoelectric voltage, the reference junction temperature is measured by an internal temperature sensor in the area of the terminals. The thermoelectric voltage that occurs at a measurement temperature of 50 centigrades is added to the measured thermoelectric voltage as an example. The measured temperature is determined for the recalculated thermoelectric voltage and displayed. All information about our seminars, webinars, e-learnings and reference books are available on our homepage.